This is a video on the conic section, the hyperbola. Just as a quick review, the hyperbola from the geometric definition relies on the cone and the plane intersecting it. Don't forget that you have to have a double cone and your plane is going to intersect both naps in order to form the conic section, the hyperbola. The algebraic definition is a set of points in the plane such that the difference of the distances from two fixed points, called the foci, remains constant. Hopefully you'll notice that this is very much like the definition for the ellipse. It's just that in the ellipse, it's the set of points in the plane such that the sum of the distances from two fixed points remains constant. And with the hyperbola, it's the difference of the distances from the two fixed points remains constant. Okay, here's a picture of that definition. If you look at point A, you can see that I have distance 1, which is from point A to the focus 2, and distance 2 is from point A to focus 1. The difference of those two is going to be constant, even if I pick a different point, like point B. If I take distance 1 minus distance 2 for point B and subtract those, then it's going to give me the same number as if I take distance 1 minus distance 2 for point A. Okay, looking at the hyperbola, we have some items that we need to reference on the graph. You can see right in the middle, right here, the center is the little green dot, and this one is at the origin. The transverse axis is the one that connects the two vertices of the hyperbola together. That's the transverse axis. The vertices are here and here, the turning points of the branches of the hyperbola. And the conjugate axis is the other axis that runs perpendicular to the transverse axis. The hyperbola versus the ellipse. We already sort of touched on this. The algebraic definition of a hyperbola is a set of points in a plane such as the difference of the distance from the two fixed points called the foci remains constant. How is that different than the definition of an ellipse? See if you can remember and answer that question. All right, facts about the hyperbola. Both variables are squared in the hyperbola. The equation is x minus h, that quantity squared, divided by a squared, minus y minus k squared, divided by b squared, equals 1. Or it can be turned around, y minus k, that quantity squared, divided by a squared, minus x minus h, that quantity squared, divided by b squared. Now let's compare the equations of ellipses and hyperbolas. Take a minute to look to see what you think is the same and what you think is different about these equations. I hope that you will notice that the difference in the ellipse and the hyperbola's equation is that the ellipse has a plus sign in between the two terms on the left side, and the hyperbola has a minus sign in between. What makes a hyperbola different from a parabola? Hopefully you'll remember that the parabola only has one variable that's squared, and the hyperbola has both variables squared. What makes the hyperbola different from a circle? Hopefully you're going to remember that the circle, if we ended up setting the circle's equation equal to 1, we had the radius squared on the denominator of both the x minus h squared and the y minus k squared. With the hyperbola, these two numbers are going to be different. All right, here are our two formulas again. I need you to be sure you understand that the center of the hyperbola is hk. Just like with our other conic sections, we get the center from h and k in the formula, remembering that the h is always with the x and the k is always with the y. The absolute value of 2 times a is the length of the horizontal axis, and the absolute value of 2 times b is the length of the vertical axis. And again, that makes sense because the A is under the X here, so that would be the horizontal axis. And the Y is under the B, so that would be the vertical axis. All right, so our procedures to graph, actually what you need to do right now is get these down. So I'm not going to bother to talk through them. If you will just copy these down, pause this video, copy them down, and then we will move on and do an example. Be sure that you pause the video again and copy down these two steps in graphing a hyperbola. Be sure you pause the video again and copy down these two. One last time, be sure you copy down. Pause the video and copy. The equation of each asymptote can be found by using point-slope form. Use the center as the point, and the slope can be found by counting on the graph from the point to the corner of the rectangle. When we go over the graph in the example, I'll be sure to show you this. You can also use these following formulas if you would like to. The horizontal transverse axis, if you have a hyperbola with a horizontal transverse axis, you're going to use the formula y equals k plus b divided by a, x minus h, and y equals k minus b divided by a, x minus h. With a vertical transverse axis, you're going to use y equals k plus a divided by b times x minus h, and y equals k minus a divided by b, x minus h. All right, let's look at this together. We're going to actually graph this one. Got some graph paper here. Get it on here so you can see it. Okay, the first step that you copy down is to put this in standard form. If you look at the equation that we have, it's already in standard form. Determine if the hyperbola is opening vertically or horizontally. Okay, hopefully you can see that this one is going to be opening vertically because the y is first. When the y is first, it's going to open vertically. Identify the center, and in this case, I hope you can see that the center is 0, 0, because this is x minus h squared, so that's the first 0, y minus k squared, that's the second 0. Let me move this over so you can see what we're doing. Okay, so I'm going to graph the center. Here's 0, 0. Identify the endpoints of the horizontal axis. The endpoints of the horizontal axis are the square root of 36, because that's the a. So a squared. So the horizontal axis is going to have endpoints at positive 6, 1, 2, 3, 4, 5, 6, and negative 6, 1, 2, 3, 4, 5, 6. Okay, that's the endpoint of the horizontal axis. The endpoints of the vertical axis are going to be the b squared, square root of b squared, which is 8 and negative 8. So I'm going to go from the center up 8, 7, 8, and down 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now we have to determine which pair of endpoints are the vertices. Okay, the vertices are always going to be under the term that comes first. Since the y comes first, it opens vertically, and that means that the vertices are going to be on this axis. because we're going to have a hyperbola that opens up and down. And I have made this really big, and I don't know if it's going to fit. Okay. Okay, now what we're going to do is we're going to draw a rectangle so that each of the axis endpoints is the midpoint of a side. So I'm going to draw, and I usually draw mine with a dotted line. This is my rectangle right here. We're making it a midpoint. This is the midpoint of that side. And this is going to be the midpoint of this side. Oops, I went too far. This one is going to be the midpoint of this side, and this one is going to be the midpoint of that side. So there's my rectangle, so that those axis points are the midpoints. Now, we're going to sketch the asymptotes of the hyperbola. The asymptotes of the hyperbola go through the center and through the corners of your rectangle. So I'm going to draw the asymptotes. Draw the other asymptote through the corners of the rectangle and through the center. Okay, put arrows on the ends. I made mine kind of big. So put arrows on the ends of those. Let me move this up just a little bit so you can see better what I'm doing here. Arrows on the ends of those asymptotes. Okay. Now you're going to draw each branch of the hyperbola. Be sure to go through each vertex and be sure to approach the asymptotes. So I'm going to go through this vertex, slide this back down so you can see, through this vertex, and we're going to approach that asymptote, through this vertex and approach the asymptote. Come down here, through the vertex, approach the asymptote, through the vertex, approach the asymptote. Still, you need to be a little further away so you can see the whole thing. Okay? Okay, locate your foci at 10 and negative 10. So that's going to be 0, 10. The foci always are inside 9, 10, and negative 10. Okay, so this will be foci 1 and this will be foci 2. And then find the equations of the asymptotes. You can either use your slope. So this is going to be, we're going to do y equals, because you can find your point here, your point in the middle, and your point here on the line, and go 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go up, rise 8, run 1, 2, 3, 4, 5, 6. Okay, y equals 8 over 6x, which reduces to y equals 4/3 x. And then you're going to do also the opposite, so y equals the opposite of 4/3 x, because this slope is negative. Okay? All right. And there's another picture of it. Okay, and then this is graph number 2. I'm going to leave this one for you to do. If you would like to go through and pause the video, try to graph this, and then go through and check your work. I'm not going to actually graph this one with you. I'll do that in class. So you try it first and then see what you can do with it. So pause the video, try to graph it, then come back to the video and check your work. Okay, here's your hyperbola. Okay, now we need to put this equation in standard form. Let's make sure that we can put this equation in standard form. Okay, y squared minus 4x squared equals 64. All right, what you need to remember is that you've got to get a 1 here. So we're going to divide by 64, divide by 64, divide by 64. And this will give me y squared divided by 64 minus x squared divided by 16, because 4 goes into 4 once and into 64 16 times, equals 1. Okay, so you've put it in standard form. Now go ahead and try to graph this. Pause it and graph it, and then come back to the video. Okay, and here's a challenge question for you. I want you to try this one, and then we'll work on this tomorrow in class. Here's your review. See if you can answer these questions, and we'll talk about them in class as well.